Hi, welcome to Concept Based. I'm John Hepworth, and today the question is a little bit different. It's define a function. So we don't have an equation up there, we don't have a graph that we're meant to draw, it's just this definition that we're being asked to give. But this is a question that's well worth looking into. As teaching students historically for myself, they definitely struggle with the language and what actually really differentiates a relationship to something specific as a function. Now, in year 10, you did a range of topics that spoke about relationships. You even then went on and did non-linear relationships, part C. You were graphing parabolas, exponentials, hyperbolas, some circles, and so forth. But they were all just called relationships. And the reason why they're called relationships is there is some sort of relationship between X and Y. So everything can be called a relationship. But there's a certain group of relationships which we can actually call a function. And most of the relationships that you've been working with actually are functions. And we're just going to have a look today and work out what it is that makes this relationship special to become a function. So first of all, when we think about what a relationship does, we can think of it as just a box. It does something magical happens in here. And in there, we essentially put numbers in, we put X values in, say the numbers 1, 2, 3, 4, and we get some value out depending on whatever it is that we are graphing or even just expressing in terms of the functions. And so, for example, here's one you have come across in year 10 many times and at the start of year 11 advanced. This is a certain type of relationship that you can probably identify. But the idea is that X values go in, Y values come out, something happens in the middle to make that happen. So what we care about in terms of something being a function is whether or not when we put one particular X value in, if only one particular Y value will come out. So obviously for this situation, as I was writing it, it appears as though 2 goes in, 4 goes out, 3 goes in, 9 goes out. So for every X value that I'm putting in, an X value is coming out. But I could change this thing to not be a function. I could make it a relation by putting the number 1 in again, but then getting a different answer out to last time. What if I put the number 1 in and got the number 2 out? Okay, so if this happens, this is a relation or a relationship. It's not a function. But if we have a situation where for every X value that we put in, we get some unique Y value. Sorry, I shouldn't confuse that. And I'll explain why I shouldn't confuse that and say a unique Y value. For every X value we put in, we get one Y value out. It's okay if we put an X value in and we get the same Y value out. So here you can see up at the 1 and the 4, I'm getting these same values out. I'm getting 1 out of a 4. That's okay. That still allows it to be a function. What the only problem is if, as I showed before, is if I put an X value in and I get 2 different Y values out for that X value. Okay, so this function is special, or we say it's not a relationship, it's a special type of relationship. It's a function if one X value results in one Y value. Okay, now that's sort of just this magic box definition, but what does that actually look like graphically? What does that actually mean? So if we were to have a graph, what it means is that if I put an X value in, I can only get a Y value out in one place. So there's an example where I've put one X value in and I've got one Y value out. That's okay. This thing is a function. I can go and put another X value in and get another Y value out. We are still in the situation of a function. But if I put an X value in and I get 2 Y values out for that one X value, then now it is not a function. Okay, so a function will only ever have one Y value come out for one X value. As a result, this creates a test that we use. And the test that we use is called a vertical line test. And so the idea of a vertical line test is to test that for anywhere on the relationship, the vertical line only crosses the relationship once, making it a function. So here's an example. If I draw a graph like this, no matter where I draw a vertical line through it, it only crosses the function once. So that means for one x value, I'm getting one y value out. I can't make it happen in any way that if I drew a vertical line, oh, that's terrible. That's not even close to a line. That if I drew a vertical line that I would get two y values out. I just can't do that with this one. They exist though. Can you think of one where I would cross that twice that you have drawn in year 10? A circle's one. So you have done nonlinear relationships circles and you've looked at the equation of a circle. So in the case of a circle, for the vertical line, we cross it twice. So for one x value, we're able to get two separate y values out. That is not a function, that's a relationship. However, if this circle was a little bit different and it was just a semicircle, now we're back in the situation of it being a function. So if we are drawing circles and we only do the semicircle, then it's a function. So when does that happen? So let's look at a really basic circle. Let's look at x squared plus y squared equals 1. So here we have a circle at the center. Center is at the origin, and it has a radius of 1. So we have this circle here. But if we rearrange this a little bit, and we said y squared equals 1 minus x squared, and then we went and took the square root. So now y equals plus or minus root 1 minus x squared. All it would take for us to just have this being a semicircle is here at this plus or minus. If we only took into consideration one of those, say the positive side, then we would only have the positive side of the semicircle, and that would be a function. So if you're looking at equations that look like this, the way of identifying that you definitely can't have two values for any given one x value is that there's no plus or minus on the square root. This can happen again in another situation that is very closely linked to parabolas. We all know what the standard parabola equation looks like, y equals x squared. But what if we wrote it just slightly differently? What would it look like if we wrote y squared equals x? What would that look like? Well, to do that, we just make it a little bit easier by taking the square root of both sides. So we say y equals the square root of x, and hey, just like the circle, we're back in this situation where there's a plus minus value. So what that actually does is it actually ends up creating a parabola in the other direction. So now we have it sort of, I suppose the axis of symmetry of the parabola is the x-axis, not the y-axis in this case. And so you can see that that plus or minus out the front of that square root is what's creating this plus value and this minus value for one given x value. But we can tidy it up and make this expression or this relationship a function by, again, if we just took the positive side of that square root, then we'd just be graphing this part of the parabola. And now anywhere on a vertical line, we would only be crossing it once. So even though circles are a relationship and these parabolas facing the other way are a relationship, we can make modifications to the relationship or restrictions in their range so that they then become functions. So when I say that in restrictions in their range, previously this graph had this bottom edge. We restricted its range by doing this plus root x. But we could also say, you know, where y is greater than 0. That would restrict the range of the relationship and make it a function, because now we just have this one bit where the line could only cross it once. So how can we be sure that we're in a situation where something is a function? The idea is that if we put one x value in, we can only possibly get one y value out. And so that's expressed a couple of different ways in your syllabus, and I sort of touched on it very similarly just then. Some examples that are given is when you have a set of numbers. This is very similar to what I drew earlier, where you link up numbers. Now, if you have one x value giving you one y value, this is a function. If two x numbers give you the same y value, that's still a function. That's okay, right? And that's what students will get confused with. I'm just going to do a quick sketch again to highlight this. See a parabola? That's a shocking parabola. This parabola, two different x values can get the same y value out. So here, let's say it's +1 and -1. Both get out +1 on a standard parabola. That's okay. It's still a function because it's passing the vertical line test everywhere. It only has one y value for every x value. So that's okay if two x values give the same y value. What's not okay? Well, what falls outside the definition of a function is if it looks like this. So now the number 1 is given both a 5 and a 6 as a solution, which would obviously fail the vertical line test because we'd be crossing the relationship at 6 and 5, and so therefore we have the failure. Now these sets of numbers can even just be given as a set, so as a essentially paired numbers. So an example in your syllabus looks something like this, where you have number pairs, and you're trying to define if this is a function or not. And this happens. And so again, you can see there's two x1s, but they give off different y values here and here, the 2 and the 4. So if you looked at this set, then you would say that this is not a function because essentially it's failing the vertical line test, but you would say it's giving two y values for one x value. So to be very specific and to give the definition that is from your syllabus here, to define a real function f of a real variable x as a relation where each element x of a given set is associated with exactly one element y of the second set. And that's what gives us our functions. Now, just to finish off, let's have a look at what you've drawn in the past. A line, linear function, or linear relationship in year 10. Now, year 11, that's a function, right? Because it's only going to have one y for every x. We've already spoken about parabolas. That's a function. Be careful if it's done so the parabola goes this way. Not a function. What else did we do in year 10? Well, we mentioned this one. Relationship, right? Fails the vertical line test. But if we restrict it to a semicircle, then we can have it being a function. You did other things as well. You did exponentials. So you did a graph that looked like this. That's going to be a function. You did hyperbolas. That is going to be a function. So most of what you did last year is a function. Polynomials now, if we were looking at a polynomial of any degree, is going to be a function. So a lot of what we deal with in the Year 11 Advanced course are functions, but there are those couple that I've listed that aren't. So just be aware of it when if some sort of definition is being given, or if you're asked to be, say, range restricting or domain restricting so that you do only have a given function, then you'd be able to do that because you understand exactly what the definition is.